Now we are going to start the new chapter, that is triangle, and here the main topics which we are going to cover is concept of similarity, concept of congruency, area of similar triangles, BPT theorem or Thales theorem, or we call basic proportionality theorem. Then we are going to do Pythagoras theorem, exercises, questions, logic, tricks, explanation, prove that questions. Now let us start with similar figures. Similar means looking like alike. So here it means same shape with same ratio or proportion, i.e. that can be on of the same shape and in some proportion. It may be 1 upon 2, 1 upon 3, 1 upon pi, like that. Okay, two figures are similar. Now, let us take one example of two circles. See, this is one circle, this one is another circle. Now, both the circles are similar as they have the same shape and they have the ratio in proportion, or you can say they are in proportion. So, they are similar figures. Now, congruent figures means same shape and same size. That means both the same shape should be same and size also should be same. So if I take the first example only of circle, so two circles will be congruent if they have the same radius or their sizes are same and shapes are. Now let us discuss exercise 6.1 question 1, that is filling the blanks using the correct word given in the bracket. All circles are similar. The reason is because they can have different radius, so size can be different but shape will be similar. Then same way, all squares are similar because they will have the same shape but size can be different. Then the third one says all equilateral triangles are similar. The reason is because all the three sides will be similar, but or the three sides will be equal, but they are not similar. Then fourth one is two polygons of the same number of sides are similar if their corresponding angles are equal and their corresponding sides are proportional. So see, if the angles will be equal, then only they can overlap on each other. And they will be similar if the sides are in the proportion. So I can say okay, that both the figures are similar. Now, coming to question 2, give two different examples of pair of similar figures. See, first I have shown a pair of squares with different size but same shape, and same way hexagon. In the B part, it is non-similar figures. So there I have shown rectangle, square, triangle and hexagon. Question 3 says, state whether the following quadrilaterals are similar or not. So here if you see, sides are in the ratio, but angles are not equal. So I can say they won't be similar figures. As angles are not equal, but sides are in the ratio. So next topic is similarity of triangles. It says, two triangles are similar if their corresponding angles are equal, and B point is their corresponding sides are proportion or in proportion. So two triangles I have shown, ABC, two triangle DEF, then angle A should be equal to angle D, angle B should be equal to angle E, and angle C should be equal to angle F. So angle A equal to angle D, angle B equal to angle E, and angle C equal to angle F. And AB side similar to this sign is of similar and DE. Then BC similar to EF and DF similar to AC. If both the above conditions are satisfied, then I can say triangles are similar. Now, next is basic proportionality theorem, BPT, or Thales theorem. It says if a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. For this, you will need to draw the diagram that is already I have drawn and shown you. So, diagram I have already shown, and here you have to prove that AD upon DB equal to AE upon EC. So, now moving ahead to writing to given, so ABC is a triangle with DE parallel to BC. That is given to me that DE is parallel to BC. To prove AD upon DB equal to AE upon EC. Now construction I am doing to prove this by simple technique. Join BE and DC and EF perpendicular to AB. Join DC and BE and make DN perpendicular to AC and EF perpendicular to AB. Now coming to the proof. Now here is an easy technique to prove, so understand it nicely so that you can easily prove it. Now area of triangle ADE upon area of triangle. See, now I want AD upon DB, so I have to use like that. So area of triangle BDE, that will be equal to half into base into height upon half into base into height. The formula I have written. Now, that will be equal to half into, see both sides I have to write half. So I have written into. Now ADE, the perpendicular is, AD is the base, so I will write AD, and in the second one I am having DB as base, so I am writing that. Now in triangle ADE perpendicular is EF and BDE also perpendicular is EF. Inside the triangle perpendicular is not there, so I am taking it outside the triangle one. So EF. Now EF cancel, half cancel. So this comes to area of triangle ADE upon area of triangle BDE equal to AD upon DB. Now this is number one. Now same way also area of triangle ADE upon, see on right side I want AE upon AC, so I am taking the triangles in that way. ADE upon area of triangle CED. So that will be half into base into height. So half into AE into DN upon half into EC into DN. So now half cancel, DN cancel. Here perpendicular is DN and AE and EC are base. So I got AE upon EC. So this is 2. Now 1 equal to 2. Triangle BDE and triangle CDE are on the same base DE. See, they both are on the same base and between the same parallel lines. Same parallel lines. DE and BC. So we know that if two triangles are on the same base and between the same parallel, they are equal. Therefore, area of triangle BDE equal to area of triangle CED. 3 number. Now, taking equation 2, area of triangle ADE upon area of triangle CED equal to AE upon EC. Now instead of CED, I am taking from equation 3 and writing area of triangle BDE. So area of triangle ADE upon area of triangle BDE equal to AE upon EC. So this I got the fourth equation. Now this I got using 3. Therefore AD upon DE or AD upon DF, AD upon DB equal to AE upon EC using 1 and 4 equation. I got this. So here my Thales theorem or basic proportionality theorem got proved. I needed to prove this only, so I got it done. This way we can do it easily. Now coming to the converse of BPT theorem or Thales theorem. If here it says if a line divides any two sides of a triangle in the same ratio, then the line is parallel to third side. Here diagram already I have shown you. Now I am taking in triangle ABC, AD upon DE equal to AE upon EC. This is given to me already. K sides are in ratio, so I have taken that directly. Now, to prove DE parallel to BC. Now, construction. Again, here we have to do construction to prove that K it is there. So, construct DE dash a line parallel to BC. Now, coming to the proof. Here I have supposed that DE dash is parallel to BC. So using BPT theorem, AD upon DB equal to AE dash upon DE dash C. This I am giving as one number, but AD upon DB equal to AE upon EC. This is already given to me, so that is second equation. So, using 1 and 2, see LHS are equal, so RHS should be equal. So, I can say AE dash upon E dash C equal to AE upon EC. Now, if this is happening, so then adding 1 on both sides, see, adding 1 is the technique to make one term disappear. So, AE dash upon E dash C plus 1 equal to AE upon EC plus 1. Now I am doing LCM on both sides. So, AE dash plus E dash C upon E dash C equal to AE plus EC upon EC. So, if you see AE dash plus E dash C, so it is coming AC upon E dash C equal to AC upon EC. So both sides if I cut AC, so I will get EC equal to E dash C. So I proved that both are the same point or both are equal. So therefore both are equal. That means E dash and E coincides with each other. So therefore that means they both are same point. Therefore I can say DE is parallel to BC. Now coming to exercise 6.2 question 1. In figure 1 and 2, DE parallel to BC, find EC in 1 and AD in 2. As DE parallel to BC, see using BPT theorem I can say AD upon DB equal to AE upon EC. Now putting the values I will get 1.5 upon 3 equal to 1 upon EC. So I can say cross multiplying them. So I can say EC equal to 3 upon 1.5. So EC equal to 2 centimeter. Now in the second figure, see AD is not given, DB, AE and EC are given. So same way I can prove this. K, DE is parallel to BC. So using BPT theorem, AD upon DB equal to AE upon EC. So AD upon DB is 7.2 equal to 1.8 upon 5.4. So again doing AD alone, so AD equal to 1.8 upon 5.4 into 7.2. So therefore AD equal to 2.4 centimeter. Now question 2 says we are given PE equal to 3.9 centimeter, EQ equal to 3 centimeter, PF equal to 3.6 centimeter, FR equal to 2.4 centimeter. So you have to prove that the lines are parallel or not. So PE upon EQ equal to PF upon FR. If this is equal, then I can say lines will be parallel. If it is true, then I can say lines are parallel. So EF is parallel to Q1. So let us check that now. 3.9 upon 3 equal to 3.6 upon 2.4. So if I cut 1.3 is not equal to 1.5. So this both are not equal. So therefore EF is not parallel. See, this symbol is of not parallel. QR. Now B1, PE is 4 centimeter. QR, QE is 4.5 centimeter. PF equal to 8 centimeter and RF equal to 9 centimeter. So here also PE upon QE should be equal to PF upon FR. Then the lines are parallel. So 4 upon 4.5 should be equal to 8 upon 9. So if LHS I multiply with 2 in numerator and denominator, I am getting 8 upon 9. So I can say that both the lines are in proportion. So therefore EF is parallel to QR. Now third one, I am given PQ equal to 1.28 centimeter, PR equal to 2.56 centimeter, PE equal to 0.18 centimeter and PF equal to 0.36 centimeter. So here again doing PE upon EQ equal to PF upon FR. So if it is there, then the line should be parallel. But I am not given PE. So can I write PE upon PQ minus EQ equal to PF upon PR minus PF. So this will be 0.18 upon 1.28 minus 0.18 equal to 0.36 upon 2.56 minus 0.36. So 0.18 upon 1.1 equal, it was 0.36. So let me do 36, so 18 and 110. So I got the EF parallel to QR. Now, question 3 says LM is parallel to CB and LN is parallel to CD. So to prove AM upon AB equal to AN upon AD. So using BPT theorem, I can say AM upon AB equal to AL upon AC. Half upon full on both sides I have taken. So that I am giving one number. Also L Ln is parallel to CD. So again using BPT theorem, I can say AN upon AD equal to AL upon AC, 2 number. Now 1 equal to 2 from 1 and 2, so I can say both the right sides are equal, so I can directly say left hand sides are equal. So AM upon AB equal to AN upon AD. Hence proved. Now coming to fourth sum, it is given in triangle ABC, DE is parallel to AC and DF is parallel to AE. To prove AF upon FE equal to BE upon EC. So here I can using BPT theorem in the triangle, it is already given parallel. So using BPT theorem, I can directly say BD upon DA equal to BE upon EC. This one is first one. Now similarly, DF is parallel to AE. So therefore BD upon DA equal to BF upon FE. So this is second number. So using 1 and 2, LHS are equal, so RHS should be equal. So I can say BE upon EC should be equal to BF upon FE. Hence proved. Now coming to question 5, it is given DE is parallel to OQ, DF is parallel to OR, and I am asked to prove EF is parallel to QR. So here to prove, I have to use again BPT theorem. So let us in triangle PQO DE parallel to OQ. So using BPT theorem, I can say PD upon DO equal to PE upon EQ. This one number. Now in triangle POR, DF is parallel to OR. So again using BPT, I can say PD upon DO equal to PF upon FR. So this giving us 2 number. So using 1 and 2, I can say LHS is equal to, so therefore RHS also should be equal. So therefore PE upon EQ equal to PF upon FR. Therefore using converse BPT, I can say EF parallel to QR. Now coming to the sixth question, it is given AB is parallel to PQ, AC parallel to PR, and to prove BC is parallel to QR. So to prove AB is parallel to PQ, so using BPT theorem, I can say OA upon AP equal to OB upon BQ. This will be first number. Similarly, in triangle OBR, AC is parallel to PR. So using BPT, OA upon AP equal to OC upon CR. Now 2 number. Now using 1 and 2, LHS are equal, so RHS equal, so OB upon B, PQ equal to OC upon C. So, using converse BPT, I can say BC is parallel to QR. Now, seventh question. Given in triangle ABC, D is midpoint of AB such that AD equal to DB. A line parallel to BC intersects AC at E as shown. To prove E is midpoint of AC. So, I have to prove that AE equal to EC. So, D is midpoint of AB. So, therefore, AD upon DB equal to 1. First number, AD and DB will be equal, so it will be equal to 1. Now in triangle ABC, DE is parallel to BC. Using BPT, AD upon DB equal to AE upon EC, 2 number. Now see, from 1 I can say and 2 I can say directly AE upon EC equal to 1. So therefore AE equal to EC. So therefore E is midpoint of AC. Now coming to the eighth sum, in given is in triangle ABC, D and E are midpoints of AB and AC respectively, such that AD equal to BD and AE equal to EC. I have to prove that DE is parallel to BC. So D is midpoint of AB. Therefore, AD equal to DB. AD upon DB will be 1. Also, DE is midpoint of AC. So, therefore, AE equal to EC and AE upon EC equal to 1, 2 number. Now RHS are equal, so LHS should be equal. Using 1 and 2, AD upon DB equal to AE upon EC. So, using converse BPT, DE is parallel to BC. Now, ninth sum, given is ABCD is a trapezium, AB is parallel to DC and diagonal AC and BD intersect at O. To prove AO upon BO equal to CO upon OD. Now construction I will need to draw is from O draw line EO touching AD at E and BC at F, so that EO equal parallel to OC parallel to AB. Now, for proof in triangle ADC, OE is parallel to DC. So, using BPT, AE upon EBD equal to AO upon OC, 1 number. Now, in triangle ABD, OE parallel to AB. So using BPT, DE upon EA equal to DO upon BO. So two number. From 1 and 2, I can say AO upon OC equal to BO upon DO. So, therefore, AO upon BO equal to CO upon DO. 10th one is given quadrilateral ABCD where AC and BD intersect each other at O such that AO upon BO equal to CO upon DO. I have to prove that ABCD is a trapezium. So construction from point O, draw a line to EO touching AD at E such that EO parallel to AB parallel to DC. Now using BPT theorem, DE upon EA equal to DO upon BO, one number, and given is AO upon BO equal to CO upon DO. So therefore AO upon CO equal to DO upon DO. So therefore CO upon AO equal to DO upon BO. So just I have reversed them. So therefore DO upon OB equal to CO upon OA. So that is number 2. Now from 1 and 2, I can say DE upon EA equal to CO upon AO. Using converse BPT, EO parallel to DC and EO parallel to AB. So therefore AB is parallel to DC. Therefore ABCD is a trapezium.